All right, we are live for day 11 of Advent of Code, and we are on an hour early. I think yesterday's problem was well deserving of a review and refactor, so that is what we're starting out with tonight. Um, I wrote some code, and I also abandoned a lot of code. So this is my code as submitted last night, and there's a lot of room for cleanup here. We're kind of just winging it and making it work as one does during Advent of Code. Um, Alka, hello, welcome. I saw your code, and I'll have to try the ray tracing, the vector even odd rule at some point. And I see other people have gone with that approach. So what is it then? Three general approaches. One, walking the path. Two, trying to be clever about flood filling, either by turning tiles into further quadrants and being smart about that, or three, using ray tracing. I guess not, it's not really ray tracing, ray casting, or the even odd rule. That's all I've seen so far. But I did not know about that, and I'm sure it'll come in handy again sometime. It also seems a lot more general. It's able to handle like a path that goes over itself, whereas this one does not intersect itself. Okay, so let's see where we were. Let's look at my output. This is the final map I'd made of what's inside and what's outside. And had I drawn other maps? Oh geez, what's this? Uh, that's just all the output that I didn't even look at. Nope, no the maps for now. Here's a map of spaces. It took me a while to realize we're not counting just spaces that are inside and outside, but anything that's inside and outside a pipe, so including other pipes, which could just be ignored altogether. Okay, let's start by going to the code that draws that. Um, so we decide right flood is I, left flood is O. We can do this programmatically and decide whether one or the other is the outside or the inside. So I might do that. Well, I will do that at some point. And I had a bunch of checks in here, which I don't know, maybe I turn into assertions. So these sizes should all add up to area.size. Maybe I should say this is an equals. Well, you know what, a minus is more useful. It tells me how many I'm missing or undercounting. What's the extension that's showing out the output? Oh, so this is a worksheet inside Metals, which is an extension for using Scala within VS Code or many other editors. So Metals has worksheet mode or worksheet file. I know JS has Quokka.js. Yeah. Yeah, no, this is completely free, but unfortunately it's only Scala. But it's I like to think of it as bringing it's like bringing the REPL to your editor. Very nice to work with, especially for admin of code, to do like all this testing and verification kind of inline. Okay, so due to these floods, I had seeds, um, and we do this. So a JSON filter. So this is how we determine where it spreads, right? We look at adjacent, we make sure area contains that. This kind of thing is common enough. I might add that to my library, right? You look at adjacent Like you look at your current set, you flat map it to the adjacent points to that, but you're always going to check if it's in bounds. So, um, what if an area itself contains an adjacent method or a point? Yeah, let's do that. So I'm gonna put that here on the right. Point.scala here. Okay, so class area. So we have this contains method. We also have in here somewhere def adjacent. Oh, def adjacent, and this is within the points. Um, we also have an inbounds, I think. Def inbounds. Is it inbounds of an area? Yeah. The area just contains this, so some redundancy there. Let's do this. Def adjacent. And this checks also inbounds. P point equals p dot adjacent dot filter contains exactly. And let's use that in here. Give me just 1 second here. I'm gonna mess with a setting. Okay. And we'll do this in all our flood fills moving forward. So area dot, according to this area, what's adjacent to this point? Right, and then we diff out the boundary points and we diff out the visited points. Okay, that seems reasonable. Left seeds and right seeds. So that's from this walk here. Let me see. And for some reason, so when I started this, I took the point to my left. I also took the point forward of that. And moving backwards of that also resulted in a bug, I believe. So let me just check that. Left dot move dir dot turn right dot turn right. In fact, I might make that method in my library as well. So in the point, so under dir def turn right. So dir dot backwards or def turn around. Reverse. Yeah, sure. Okay, we now have a reverse method. So dir dot reverse. And let's add that here on the right as well. Right dot move dir dot reverse. And yeah, so some numbers change. This is not good. I wonder what it is about that. Like, is my code only accidentally working on the one that hasn't moved forward? Hmm. Let's look at a map. Oh, you know what? Before I move on, I might make a better printer here. So def power to pipes. Yeah. So now let's see. Unicode bottom left pipe equals what is the code? There we go. This is how we do this. Print Unicode bottom left pipe. It's not quite the pipe I'm looking for. Well, let's just comment that out. Let's try again. Val Unicode bottom to left pipe. It's giving me the same character. Okay, I guess we have to look him up. Unicode, pipe characters, box drawing characters. Here we go. And we can even make them look very pipish. Okay, so let's keep that. Let's keep that in there. Oh, okay. So the 7JLF. Amuga, hey, welcome back. Welcome back to the stream. We're just reviewing the factoring day 10 right now. Maybe a little bit in the warm up for day 11. How's your admin of code going? Korean? No, not Korean. These are pipe characters. We're going to draw out day 11 or day 10. So the 7, for example, we want the pipe that goes up and left. This one right here. U2557. Oh. So we do that. It's this 2557. You're not doing it with code. Pipe characters. Okay, here. I can give you an example real quick. So we're going to do like an area.draw. We're going to draw the map as they give it to us. The grid. Okay, so we're given this map, right? And there's a pipe running through this map. This L here, for example, tiny little L, it means the pipe goes down from the top and then moves to the right, and it hits a J, which means it goes from the left up. But that's not very visible, right? It's not clear because there are just L's and 7s and F's and J's. So we're going to make them look better. Yeah, type characters, exactly. This would return a character. Okay, so back to this. There we go. So the J, it goes left to top. That is 255D. 255D. And then the L. I mean, I suppose I could copy paste the character itself, right? L can handle that. I wonder if I should do that. Let's look at the L character. 255A. I hope I lost it. Okay, here. Yeah, honestly, I prefer that a little bit more. Okay, so we copy paste all of these. It'll be a lot more visible. And then the 7. And then the F pipe is right here. 2554. Okay, and then we have the horizontal pipe. 2550. Sorry, this is a painstaking work. Kind of boring. The S We just know that's a J, so we're just going to do that for now. Or, I wonder, can I emoji that to like the star? This is our starting area. We'll try it. The dot can stay as a dot. And the vertical pipe is missing. Um, what was the vertical pipe character? Was it just, yeah, it's just a normal vertical pipe. So case, you've been doing this course. Oh yeah, you've been doing 9 to Tetris, the best thing ever. Oh, great, I'm glad you're enjoying it. Yes, yeah, it does make the learning curve easier that way. Cool. Well, I hope you keep telling me how that goes. That course is one of my favorites, one of my favorite books. And then case whatever. I think anything else becomes a question mark if it turns out that we missed a case, but that should cover everything right there. Okay, now let's print this. See how it's looking. So what is this card? Pipes, grid P. Copy worksheet output, look at our scratch. Oh my god, look at that. Look at that. That is so much nicer. Interesting. Oh, wait, does this not align properly? Okay, the star does not align properly. It's too wide. Okay, so we can't use a star. Let me see. Is your company hiring junior devs? I don't know. I'm looking for a company myself, to be honest. But ask me again in maybe a month. Interesting choice. I think I'll just leave this as an S for now. You still can't read it? Oh, it might be too small. Um, okay, let's see how this looks now. Okay, this point is inside. Wait, interestingly, this point is outside, but they're in the same place. But I got the right answer. Okay, let's zoom in on that. Oh boy, can't zoom in on that. I have to disable line wrapping for that to work. But can you see this on my screen? Isn't hold on, I have a way to do this. Okay, can you see that? This I is very clearly in the same space as this O here. This O should be considered inside. Oh wait. Yes, of course we currently have a bug because right here, where is it? We just changed something. So of course my code is not working right now. But this can give me a clue as to why that doesn't work when I do it that way. Right, so this is the path. Um, I suppose if it looks too far behind it, does make sense with looking forward if you have a turn. But if you are coming from a turn, like here, then you don't want to go search backwards necessarily, because that could be like pretty out of, okay, that makes sense. That makes sense. So, we just delete these. Is it supposed to say day 11? Oh, you mean my title? Yes, it is supposed to say day 11 because I'm here for day 11. This is just our warm up. I wonder what's wrong with my. Okay. So we fix that, and we fix this. My key bindings are not working. I don't know what's up with that. I might give VS Code a restart just to see. You're going. You're learning DSA. You don't need to learn DSA to land a job, but it's a useful thing. Yeah, stop by. Stop by. I'll keep asking about NAND Tetris. Okay, so this code here is no longer relevant. I can just delete that. Boundary points. Okay, filter not boundary points. And filter at its inbounds. Okay. Um, is something taking longer to evaluate this? Did I change something? I changed something. Oh, okay. No, it's still working. Okay. So this is my walk method. I'm still happy with it. Left seeds, right seeds, and then we flood. This test here is reasonable. Um, these tests are also reasonable. Uh, hmm, maybe I put these up here. That should be 0 there. We can make that insertion. Well, I don't know. Let's leave that at that. So the seeds we'll put separately, left flood, right flood. Boundary size, yada yada. And then this is the unaccounted. And that's fine. Um, same as this right here. Okay, and then we can have a name here. So val inside points equals, so now if left flood that contains point dot origin, then it's a right flood. Let's just then right flood, else left flood. One of those has to be it. Okay. Ooh, 1986 morning. Good morning. Refactor time. Yep, it is refactoring time. This might have been the hardest one so far. I agree with you. Well, let's see. A couple nights ago, that one was pretty hard to remind me. That was the cycle detection one. I think this one is hard depending on your approach. Like trying to squeeze between pipes is, I'd say that's a harder approach than doing either the raycasting approach or my walking partitioning approach. Um, we're gonna assign both inside points and outside points at once. So we'll say inside and then outside. So if left flood contains the origin, then right flood is inside and left flood is outside. Otherwise, we have left flood and right flood. There we go. So how did I solve part two? Well, I can show you real quick. Um, basically, so we have our pipe, right, that goes in the loop. I start at a point within that pipe. Um, and I start with the direction. So I keep track of the direction that I'm facing and I walk along that pipe, right? So my next position is just moving with that direction. And then there's a left and a right turn or whatnot. Um, and then as I'm walking through this pipe, I look at the space to my left and I look at the space to my right, and I decide that those two, no matter what, they're going to be in different sets. So one of them's going to be the outside points, one of them's going to be the inside points. We don't know which is which, but we just know that they are separate. So I keep track of those, and what I'm returning as I walk through this loop is the left spaces and the right spaces. Um, and that doesn't finish everything, but does give me a set of points that are within the left side and a set of points that are within the right side. And from there, I just flood fill off of those left and right. I call them seeds here. So I flood using those seeds, and then that gives me a two sets, an outside and an inside. And then I can do here. So if inside P, then we write I, else if outside P, then we write O. I'm just going to do an assertion here. Assert inside that intersect outside is empty. It knows what I want to write. There we go. So if outside, let me draw an O. Else if boundary points contains P, then we use car to pipes of grid P. Oh, we do have an unaccounted. So if it's unaccounted, why don't here, in this case, let's draw the block Unicode. I guess we don't even need to do unaccounted contains P. We just do else block Unicode. Right, and we only need one drawing. And then hands 2 equals inside dot size. We're going to delete all this old code here. That's not helpful anymore. We have our assertions. I will leave these tests in for now. I'm just going to make this an assert that equals 0. And our flood method here looks good. I scanned the grid. Okay, so blue 1986. I scanned the grid and checked horizontally whether you crossed the pipes and kept track if you're inside. Yeah, that's a good way to do it too. So that's what I called the raycasting method earlier. Did you explicitly use the even odd rule, or did you come up with something yourself? Because the even odd rule is more general. So it handles a pipe that crosses over itself. This here is how I determine what the next direction is based on where we are in a, I don't know. So we have a position, we have a direction, we move, If we're moving north, we might continue moving north, right? And I'm wondering if there's a way to generalize this a bit nicer, right? Like, do these wests have something in common? Um, Look at this. So, I mean, if you're moving south into a J, but the thing is, so I mean, there's another J here, right? J could also mean north. So it really does depend. Yeah. I can simplify this a little bit by saying, what is a grid at that position, right? And I don't have to do this check down here. Um, so we can get rid of this check. There we go. So if we have north into a pipe, we continue going north. And I think might as well make that explicit. West. Most guys in the company leaderboard gave up for you. What company is that? I can see that happening. What am I drawing here? Oh, I'm just drawing pipe points. Okay. I don't need that anymore. And we had our answer one. So we had this method called step point. And what this is an iterator of, I guess, steps if you're walking away from a point. So you're walking like in both directions at once. What should it actually be called? I don't think I need P's. So ands one. So fill loop, I guess I could call it. Loop steps, I suppose. Yeah, let's call it that. Loop steps. And loop steps. And oddly, there's no size. You can't get the length of an iterator, right? Can you? No, you can't. And we can determine the boundary points also using loop steps. Hmm. I think I should just turn this into a list. I'm not ever going to do this. We don't need this as a method, so I'll call this loop steps. It takes no parameters. We're going to get a list of a set of points. We'll call this steps, and what we return is steps.toList. There we go. And then loop steps.length -1, and -1, that's our answer, and all the boundary points that we'll use in part 2. You'd also probably do this by dividing boundary points by 2. I don't know. I'm happy reducing that with union. So we'll call this loop steps. This no longer needs a parameter. Okay. We're still happy here. We have a potential mismatch here. Yeah. Just have that be an exception. That's fine. We don't really need this test code anymore. Um, okay, now this adjacent method. So whether something isn't adjacent also has an additional check. It depends on where you currently are, right? If it's a pipe that has a north opening, for example, and it also depends on where you're going. What I could do is make this an enum, and then the enum could have methods on this, like where are the openings, right? So if bot is open, then if we're checking north, we just check that our current has an open top, and we check that our destination has an open bottom. I think that is what I would like to do. I'll make this read a little bit cleaner. Um, and honestly, that can also encode my this method here, this caret pipes. So we're going to do use blocking code. Just inline it there. In fact, maybe we print. No, we'll just leave it at that for now. Okay, so we find our S point. That's fine. S is a J. We have to determine. I want to do this more programmatically. So I inferred that S is a J. We know it's only adjacent to 2 points. So let's do that after our pipes. So we have enum pipes. That's not quite the names I'm looking for. So we have case. So we have like a vertical pipe, right? And then we have like a bot to left, top to left. We can name it like that, top to bot. So let's say top bot, right? And then we have top left, top right, and then we have bot left, bot right, and left right. Exactly. And then we have a few methods. So def top open. So if it is top, 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 true, otherwise it's false. Perfect. Oh, and Copilot knows autocomplete. So def bot open this match. You know what to match? Yes, yes. Okay. Def left open. I should have just done this last. So I hesitate to write this kind of code because you have to write this boilerplate, even though I know it'll make my life easier. But now that I have Copilot, I should just write this boilerplate. Case, anything that has right in it, true, otherwise false. I suppose these could also be represented as tuples of directions. I'll write a note. So note, alternatively, tuples of directions. Tuples are kind of sets. Yeah. And I already have enum for my direction. But let's do that for now. And when we parse our grid, we can parse the characters into those pipes. So grid is a vector of string and we want to change that. So I'm going to rename this grid to input. Name symbol input. And actually, do I even still need to represent it as a grid? This can totally just be a map. But we could write val grid, which is going to be a map, a point to a pipe. Pipes. I think we can rename this a pipe. Oh, okay. There are. It's not just pipes. There are different kinds of tiles. Okay. So we could say like a pipe extends tile, and then we have enums extend each other though. Enum tile. What problem does it have with this? I think just anything else, any other pipe. Um, Anything else would be false, right? That doesn't need to be. So there are empty. And I think we just call all of these tiles. No need to have a hierarchy here. We can add a hierarchy if it becomes necessary. So we're not going to extend. Um, yeah. Yeah, that works. The grid is a map from point to pipe. So we can do like an area that points to iterator. And this area will be shared by the grid. So area that points iterator. And then we map. That's not what I was thinking here. So we look into input at that point. We also kind of want a values iterator. I think we want to do something more like this. So for row and y from input zip with index or character, and x from low.zip with index, we're going to yield. And then we're going to match on the character exactly. And it will look much like this code here that was matching from car to pipes, right? 15 more minutes. Time to get the first coffee of the day. Or the last one if you're in my time zone. Um, this. This needs to all appear below the pipes. Oops, so above the adjacent method. I am in Eastern United States. So for me, the problem drops at midnight. And this can be map point to pipe. I guess it's not pipe anymore, it's a tile. We'll call it pipe for now. This here gets called empty. Tile, or what is it? Pipe.empty. Okay. Pipe dot bot to left. And in fact, let's import everything from pipe. Import pipe dot star. That's empty. Bot left. Top left. Top right. Yeah. Yeah. Well, the trick is to get a job on the East Coast, to work in the East Coast, get a remote job that's on the West Coast. Then you don't have to roll into work until noon. And as long as you finish admin code by 3 a.m., you still get 8 hours of sleep. Wake up, have your breakfast, and you're right on time. And then this is left, right, and this is top bot. And this special point, it is a start. Let's just give that a name here as well. I'm not sure if I will do that exactly. And the triple question mark. We don't know what to assign it to. Oh, okay. We should do this separately. Val tile equals car match. And all of this. So we match the character. And then what we return is point to tile. And we have a problem. This is returning a vector. I mean, let's see, map has a method here, from specific, from an iterable of some sort. And this will be point to pipe. Like again, pipe, I'm going to rename as tile. Map does not have from specific really. Map dot, I guess from. Yeah, we'll just do from. Okay, that works, that works. So now we have a grid. And this pipe, I'm going to rename to tile. And no, right, did this autocomplete here. Just any other case, we have faults. And tile needs a toChar method. So def toChar. This match. It knows. Wait, top right, bot left. No, this isn't bot left. Bot to left is 7. Okay, it doesn't quite know. It doesn't quite know. So if it's top bot, that's right. Top left is J. Top right is an L. Bot to left is a 7. Bot to right is an F. Left right is a dash. Empty is a dot. And start is an S. Okay, nothing should break further down here. Oh, well, I mean, we're still using the original input. So we can translate things over. Great. So we make sure the destination is inbounds. And now we check that the destination is open on the bot. Oh wait, what happened here? Okay. So we check that the destination is open on the bot. And we can do that by grid p.n.bot open. And then we also do a check that grid p.top open. And that reads so much nicer. Very clear what my intention is there. We still haven't programmatically determined. So start will appear in these somewhere. So start does have top open. So I'm just gonna sneak in start here. And we can change that later. Start also has left open. There we go. And now we can write all of these. I hope that is able to determine by the example. So south equals option not 1. So current that bot open, destination that top open. Great. Val E. Okay, see, and this is one reason I should have done this in advance, is now that there's semantics, Copilot is able to autocomplete this correctly. Okay, I say correctly. That was almost correctly. No, that is exactly correctly. Great. Now we don't need this inbounds check. Okay. So we're starting to remove the use of input. Next direction here. Okay, this can be made more semantic as well. Right? Yeah, the top is open going north. Or rather, if this is a bot top, I'm not sure if my methods can. I am running out of time on this refactor. Let's try this. So dir, and then grid, odds that move dir. Let's match. And can it determine from here the entire match? Come on, you can do this. Okay. Top and left. Yeah. And this is no, it should be bottom left. Valdest. We'll call this dest tile. Dest tile, and let's see if autocomplete gets smarter after adding those semantics there. So, case. Okay, that's correct so far. Nope, it needs to be bottom left. Bottom left. Case. Bottom right. Direction not east. Okay, it is getting it. Case. Top bot. Okay, case. Top and left is west. Great. So autocomplete is getting this. Exactly. Exactly. Wait. Bottom right. No, no, no. This is not right. So for destination, it has to have left. For moving east, the left has to be open. So, um, let's say bot left. Then we're going south. Oh, I'm nervous if it's gonna keep working because this does require like a case by case thinking. Um, Case top and right. So we're going from the right, we're going top. Okay. Coming from the right, we're going bot, so it should be south. Exactly. Okay. And otherwise, we do that for now. I mean, there's the J case. But we won't handle that yet. I do have tests. I have tests littered through here. So tests can keep checking my refactors. Um, yeah. So where else do we use input? So just to recap right now, I'm replacing my raw input with a grid that actually has, you know, an enum of tiles. Oh, time enjoyed. Welcome. Yeah, good luck, have fun. You too. I haven't seen you streaming lately. Are you not streaming it tonight? You're not doing AOC anymore? Oh well. It was it was the fun late night hangout. Now I don't know where to go afterwards. That's cool. I appreciate the lurk. Um, hmm. Yeah, completely agreed with you. Um, well, this is still working. Let's just let's just see where we are right now, because we're gonna have to. Okay, so my map is still working. This is all the outside points. This is all the inside points. The eyes. Hmm. And that is where day 10 will have to rest. So you get the idea of where I'm going with this. I think I'll finish the rest of this cleanup offline. Um, and as always, it's on my GitHub, which is that link right there. In fact, I'll commit what I have right now. Yeah, advent of code. I get that running out of steam. It it does take it out of you. It's a big commitment. Um, so we're gonna add our day 10 changes, and I'm just gonna commit the partial unit the message 2023 day 10 partial cleanup, and we'll push that. Um, Trying not to say my password as I type it. And that is my alarm. So turn it off. And let's get ready for real. Okay, we need a new worksheet for day 11. Yep, yep, that's an alarm. Everyone who's doing it, now it's time to start. Um, we don't need this right now. Oh, I meant to do some code review. There were some interesting alternative solutions, but I know. Save that for another time. Day 11 drops in 15 seconds. Oh, the leaderboard. Okay, it's dropped. Let's look at the input. Ooh, another grid problem tonight. Ah, interesting. Okay, so there are a bunch of points. We can handle points. Hot springs, observatory, yada yada. What is the question? Whoops. Okay. Expand the universe, then find the length of the shortest path between every pair of galaxies. Okay, so every pair of galaxies, what is the sum of these lengths? Oh, interesting. So shortest path, and it's like a Manhattan distance. This path has length 9 because it takes a minimum of 9 steps. Okay, so between every pair of galaxies, we do that. Can I just brute force this? Okay, so Val, so again, we have another grid. Val points equals, well, let's start with an area. So val area equals area of the input, val galaxies, points iterator. How did it know? How did it know? Okay. So those are my galaxies. And for, I don't know, we can do an iterator. Okay, so for G from galaxies and H from galaxies, if G is not equal to H, then we yield G dot dist to H. Now, distance is okay. Blah, 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 blah. Shortest path between all pairs, the sum of them. Okay, so val as 1 equals distances dot sum. And of course, you know, that's an n squared, but how many n's are there? Um, okay, it's not running. My worksheet is not running. I have the code. Come on. Oh, you're costing me ranks right here. Okay, let's do galaxies dot size. How many galaxies are there? Some bit of code has to run, right? We evaluated, ignoring. Okay, there are 437 galaxies. We have 437 squared. We can do an n squared with that, right? Okay, there it is. 35241. 35241. That's annoying. Okay. Not quite right. Right. There are 36 pairs. It should be 437 times 436, right? So distances dot size. How many of those are there? Galaxies, set of points. Oh, wait. I'm double counting. I'm double counting. Okay. Val galaxies v plus galaxies. We're gonna just do that 2 vector. Okay. And then we're gonna do indices. For I in galaxies indices, and then for j in 0 until I. And then so g equals galaxies I and h equals, okay. Now we do that. So we like doubled what we were supposed to get. And now this new answer should be it right here. As soon as it runs. How long is it taking to run? Come on. Come on, this is an easy problem. Um, it doesn't seem to be running my worksheet, right? Like there's normally an evaluation pop-up that comes up. Oh, this is annoying. Let's do something. Here we go. We can calculate that. I don't know. Let's just comment this out. See if we can get it to calculate at least 2 plus 2. Maybe I do this in a REPL. I'm gonna have to do this in a REPL. It's not running my code. Um, I know what I'm gonna do. I'm gonna copy this, and we're just gonna copy it into our day 10 worksheet, which we know is working, right? There we go. That's a much larger answer than it was before, which is worrying to me. Um, but let's try it nonetheless. 9029606. Okay. So G and H are distinct galaxies. G and H are both points, right? This check should no longer be necessary here. These V indices, G from galaxies.size, distances.size should be 437 times 436. That's the number of unique pairings between galaxies. Choice for first one, and then divide by 2. 95266. Okay, so distances.size is the right size, right? How many distances am I missing? Am I missing something about this problem? It says 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 steps away, right? Let's say I know. Let's look at this. So 0.00 dot dist to 0.11. That should be a distance of 2, right? By the same kind of metric. How many movements until you're on that? Lowest path between every pair of galaxies can be found. Researchers trying to figure out some of the lengths of the shortest path between every pair of galaxies. Here's the catch. The universe expanded in time. Light. Oh, the universe is expanding. Okay, and so I did just miss part of the problem. Gravitation, only some space expands. In fact, the result is that any row or column that contains no galaxy should all actually be twice as big. Okay. So it's not just dist. So we have a special dist function. And if any of our indices, empty indices, now empty indices. Okay, so let's take galaxies. In fact, at this point, I turn galaxies just to a vector. And then we don't need to use this galaxies V. Okay, we're gonna map to all the x coordinates, and then we're gonna sort them. And we're gonna have a special distance function. Wait, we're gonna make them distinct. Distinct dot sorted. And we're going to diff that against so galaxies dot indices. No, not indices. So we're going to take the area dot x range dot diff, and we're going to diff out these x. So val x occupied. So we're going to diff x occupied. Okay, so for every one of those that is in the distance, so val y occupied, same kind of thing. Autocomplete can get this area.y range, and then val, this is called x empty, and val y empty. And then we have a new distance function, def dist, between 2 points. And then we just take the normal dist and we add the number. So a dot x to b dot x. So we have this range, and we count how many are empty. So val empty crossed x. Okay. Oh, there's a between method. I don't believe that. No, there's no between method. Cool. So now we do a dot x to b dot x. And we intersect with x empty exactly. Or we count. We do a count. X empty dot contains. Yeah. In fact, maybe this should be a set. Yeah, I'll do a set for now. If it's like a sorted list, do other efficiencies there. So, well, empty crossed y, that's going to be the same kind of thing. A-y, b-y. And now we do a dot dist b plus each of those. And now we replace that down here, dist gh. Okay, so that is a true different distance here. So it is 9163477. Okay, not quite the right answer, but at least we understand the problem now. Let's try it on the test data. So we have this here. Day 11, 2023. Let me save this as an example. Okay. Great. Now when we run this on the example, we get 316, which is not quite right. Distance.size, there are 36 pairs, so we have the right number of pairs. Between galaxy 1 and galaxy 7 should be 15. Let's look at that. So dist between, let's do this x and y. So this is x is 0, 1, 2, 3, 4. 0.4 and 0, y, and galaxy 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10y, and x is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0.910. Okay, so we get 15. We are following some, but we are missing a rule. Expanded universe. Therefore, it looks like this. Each of these, only some space expands. In fact, the result is that any lower column that contains no galaxies should all actually be twice as big. Oh, they're showing me the expanded galaxy. I did the indices. I did the locations in the expanded galaxy. But that means that, dot this here should be 15. Okay. Okay, what are the actual indices of these then? So it's still point x 0, 1, 2, 3. So point 3, 0, 3, 0, and point 0, 1, 2, 3, 4, 5, 6, 7, 8. Point 8. And is it really 8? We're looking at galaxy number 7, right? I should put two that are closer together. Between 1 and 7. So, yeah, that's this one down here. 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 on the right side. 8. And from the left side, it's 0, 1, 2, 3, 4, 5, 6, 7. Okay. And it's 15. So I'm getting the right answer there. Right. But when we do it between all 36 pairs, some of the shortest path between all 36 pairs is 374. Distances dot sum. So we do indeed have 36 pairs. It looks like our dist function is working properly. There's probably an edge case where they're on the same row. Okay, let's look at this. So dist between, let's put them both in the first row. So point, let's see, let's say 0, 0 to point, 1, 0. That makes sense. If we cross over one of these, so let's say 4, that seems to be working properly, right? Because if we do like our dot dist, our usual Manhattan distance, that will be lower. Uh, okay, so if you don't have an edge case when they are in the same row, probably don't have it in the same column. Oh man, I should have this solved by now. And the universe was a minimum of 9 steps. I wonder if like the direction you go could matter. No, because no matter what, you have to cross over some amount of space, right? Crossing extra south or extra to the. Oh, my approach. I think I understand why my approach doesn't work. Right? Because my approach assumes that if you add more space here, the Manhattan distance, the vertical part of the Manhattan distance will be increased no matter which path you go. Well, I mean, it would be. And similarly, the horizontal part will increase no matter what path we take, right? If we were to go to the right, we cross over something. And if we go down, we cross over something. Hmm. Hmm. Oh man, I had such a strong start. Do I dare look at where things are here? I don't dare look. I know I'm falling behind. We don't think about that. A dot y to b dot y count y empty. Hmm. Let's look at our x empty column. So x empty dot to vector dot sorted. Right, 258 are x empty rows rather. Did I mix up x and y here somewhere? These are the x locations. We have the x range. Oh, yeah, we're checking the x range, but this is actually the y empties, right? These are the columns that are empty, right? So if we swap something here, um, so mhm, these are the x values that are empty and cross over them when we're looking at a dot y. No. When we're crossing from a dot x to b dot x, right? We cross over a bunch of x values that are known to be not occupied by anything else. So that is correct. And in fact, our dist function does work, right? We have this example here for which it works. There just must be some example for which it doesn't work. So let's look at those. Um, well, let's see. We could do a test for 3 and 6 and 8 and 9. Let's do this. We're going to print all of these distances. We're going to do val d equals the distance between g and h, and we get print line, and I'm going to do it. We're going to print g, h, and d. That's fine. And while we filter, well, places where distance is one of those. If d, or if rather set 15, 17, 5, just to find the examples that contains d. Okay, so there's 117, and it's from 09 to 71. The 17 here is from 3 to 6. So 09 to 71, that is not the same point. Okay, so that tells me that our 3 to 6 might be wrong. So let's look at that. It's the last one on the right side, first one, and then first one on the left side. Okay, so val gal 3 equals point Um, x is 0, y is 2, val gal 6 equals x is area dot x range dot max, and then our y value is 0, 1, 2, 3, 4, 5, 6. And what do we get for dist between those two? 17. Oh, okay, we do get the right answer. 0, 2 to 9, 6. But here, did we even get 0, 2 to 9, 6? For 17, we got 0, 9 to 7, 1. Oh, it could be. It could be that our dist function here doesn't work backwards necessarily. So let's do gal 6 to gal 3. Yeah, it doesn't work backwards. So it had assumed a sorting. That's what it is exactly. So we have xd, and we want xd dot sign, or rather, let's call it dx. Um, and I think we want to do b dot x minus a dot x. Val dy equals b dot y minus a dot y. And then we have to do a by dx dot sign, fix that y to dy dot sign. Okay. Okay, now other things are failing. A dot x to b dot x by. Oh, I think I did invert it. Okay, let's say this is A, this is B. No. Let me think about this. So if we're going from A to B, let's say B is bigger, so B minus A will be positive. So you do want to have B minus A dot sign. Um, okay, let's print all of these and see what's going wrong. In this case, dx delta x is 1, delta y. Ah, yes, delta y is 0. So in a 0 case, we just do by 1. So if dx dot sign equals 0, then 1 else that. Okay. And we need to write that in parens. Okay, that makes it work. And now my distance works in both directions. And we get 374. Perfect. So we can comment out all this test code that we aren't using anymore. And now we get this. Okay, that's it. We have 9648398. 9648398. Okay, part 2. Galaxies are much older than the researcher initially estimated. Make each empty row column 1 million times larger. Okay, well, that can be handled very easily. So dist. I mean, I might need to convert to longs, but my approach works. So this is times 999. Yeah. 999, 999 times 999, 999. And we solve it instantly. 325120,190. Hmm. Okay, not quite right. Let's check for the example. Okay, it might be like an integer overflow. Let's see if we get each row should be replaced with 1,000,000 empty rows. Each column should be replaced with 1,000,000 empty columns, which means you add 999,000. If each row is merely 10 times larger, in which case we would just multiply by 9. Then the sum of shortest paths would be 1030. 1030. Yeah, that works. That works. Um, so my code is working. I think it's just integer overflow. So we can handle that. We'll do a check to make sure there are no negative distances or something. So let's do this. Distances that for all just greater than 0. They are all greater than 0. So why don't we do like distances dot map dot too long, and then we get the sum. There we go. There it is. It's an integer overflow. I called it. Okay, 618800410814. Okay. Well, that was an easy one today. Someone said Dijkstra. I don't think we need Dijkstra tonight. We didn't need Dijkstra tonight. How did I do? Okay, 3,000-ish. Suppose I made good time on the delta here because my approach generalized pretty well. And here on my own leaderboard, let's full screen this. What did I do? I did 4th place on both parts. Look at my delta though. Not for that overflow. It's the fastest by a good bit. So I'm happy about that. I have a little win today. This is the Scala Center leaderboard, and I'm the first to complete both parts. So that's my first medal in a while here, and that feels good. How am I doing? So with potential, Jan Peter can still get ahead of me. Well, let's see if that happens. Good luck, Jan. And as for me here, a lot of people have potential to get back ahead of me as soon as they finish part 2. Okay, let's do a little bit of cleanup here. We've got full screen this. There are a lot of checks here. Let's see, we didn't need to do any sorted. We can, these can be sets. 2 set, and this will still work. And let's add a factor here. If y occupied, do that with a set of int. Oh, x range. You're diffing against another range, I suppose. I guess we can convert it to set beforehand or filter not. There we go. You don't need this. This whole thing can be made a little bit cleaner. We could say min x to max x and not have this sign. But we can default the sign to 0 up here. Yeah, I'm not sure. If sign equals 0, then 1, else. Empty crossed x is only ever going to be relevant when, the x is not 0. So, like, we could do if dx equals 0, then 0, else we have this. I think that reads a little bit better. Then you can do dx dot sign dot count empty. Yeah, if dy equals 0, then 0, else. Still like a long line. But it works. And we have now a growth factor. Um, we'll make that an int. You know what? We're just gonna return long out of here. So let's say long, and then we're gonna multiply it by growth minus 1 and growth minus 1. And now the growth factor here. So this now acquires the growth. And we pass that along here. Now val ends 1 equals distances 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 the growth factor of 2 dot sum, and val ends 2 is distances with the growth factor of 1 million dot sum. That works. That works. I'm happy with that. So let's commit that. Oh, wait. This should not be in the day 10 worksheet. So that was another little hiccup I had. Good thing. So we're going to revert all the changes in here, and we're going to put this in our day 11 worksheet. And now it runs. I think next time I'll just run my worksheets in advance, make sure they're actually starting to evaluate. And now we can restore. What is it? Hit restore day 10, and then we add day 11. One interesting thing about additive code is that difficulties oscillate quite a bit day to day. Yeah, it's hard to predict. I think they're generally supposed to get harder over time, but it's hard to predict how, it's not going to be the same difficulty for everyone, right? Some people find certain problems harder, and some will find them easier. And I'm going to push this. And once again, all my code here is on GitHub. They're coming in from YouTube. That's just down in the description. And I'm curious to see other solutions. So if you have a solution, feel free to post it in my Discord here. And maybe I'd be happy to review it on stream. Unless you don't want me to, but I'll be happy to review it regardless. And of course, my leaderboard. Time enjoyed. Did up to day 6, excluding day 5. Yeah, day 5 was a tricky one, especially part 2. Because you had to have that efficient range calculation. Um, you know, we have a little bit of time. I could finish my refactor day 10. Let me see. So we are almost done with that. Right, we just need to stop using input everywhere. Input, and then we need to programmatically determine. Okay, so we need a toString method. Okay, we have a toChar method. So what we could do here, the boundary points contains P, then we use grid P toChar, and that will print that nicely. I no longer need this carter pipes method. Where else are we using input? That is the last place we're using input. Okay, our tile enum is a little bit large, but like in my defense, this is auto-completable with Copilot. I think as we parse the map, like we should get the start tile up. But when we parse the map, we should turn S into what its tile actually is. And val start tile type. So we're gonna get a tile. And then we do grid start. We look north and we look at what connects. So we don't look at the grid. So we're gonna look at we'll look at start.north. And okay, and then we just do all of these. And then we can do like a north, south, east, west. How would you rate day 7? I would have said that was harder than day 6. Right? Let's look at day 7 real quick. Oh, wait. It wasn't harder. Ah, Day 7 was one of those days where I was solving the wrong problem for 2 hours before I realized what it was. After that, it was easy. After that, part 1 took me like 20 minutes. Yeah, part 2 was a bit trickier. Not too bad though. I spent longer solving the wrong problem and wondering why it wasn't working than I did solving both part 1 and 2 together on day 7. So my time was twice as long, more than twice as long as it needed to be. Don't remind me of that. But you know what? I clipped the moment I realized what was going on. So here we're going to match. And then actually, it doesn't matter what those are. Let's say if north.plot open. s.top open, then this is a top bot. We have a huge if else here. Okay, the north.bot open and west.right open, and this is a top to left, and this is what it's actually going to be. Is this autocomplete all correct? Open, left open, top right. Yeah, so this gets it. Else, we don't know. Those are the only cases we really care about here. Okay, now we parse our grid. If we see a S, we do start tile type. Day 8 part 1 was also not bad. Part 2 was more a problem. Let's look at day 8. What had to change for part 2? Oh yeah. Yeah, we had to do more we didn't have to realize that it ended on a Z at the end of a direction cycle until part 2. That was like the key insight, right? Day 9, I think, was the easiest day of them all. Like, ChatGPT could solve day 9, it couldn't solve day 1 through 3. Honestly, doing all the part 1s is a reasonable goal. It's a very valid approach to have in our code. Um, okay, so like now my code has a lot of boilerplate, which I'm not like especially happy about, but oh, it has a problem with this. Not found top bot. Oh, we have not imported it yet. So we should define this down here. And now it has an issue with this. Oh, because grid is not defined yet. Okay. Right. So we're still taking from input. And then we need a function. So we need a function object tile, and we need from car def from car. And then we're just gonna copy this code here. No, nope. Oh, okay, we're going kind of circular here. Mm, okay, starting tile type. Um, yeah, we can have a from tile method, and if it doesn't use the S, then we're fine, right? We're fine. Okay, so from tile, def from tile, just copy this match over. Insert, we're not doing it to S, we are totally fine. And then we do like tile from car. And now this works. So tile equals tile that from car. And in fact, we can just put that right down here. Okay. So that cleans up this code down here a bit. All of the big match boilerplate is above. I mean, except for this next direction. But I think this works. This is what I'll consider to be my cleaned up code. And let's add that. Looks good, that looks good. Okay, and just to make sure this is still working, let's look at our map here. Wait, what? Grid.toCar. Oh, we don't need to convert it to oh wait. We eliminated the pipes. Okay. You know what? That was somewhere in these diffs here. No. Here it is. Okay. Let's copy that. Copy that. We need to add this back in. So toCar. Top bot is this right here. The J gets replaced with this. The L gets replaced with this. And then after we do all of this, we'll be back to pretty printing. Finally, wait, what are we missing here? I think we got them all. Okay, yeah, we got them all. Okay, now when we do a copy worksheet output, evaluate. Okay, copy worksheet output, go to scratch. Beautiful. That works for me. Okay, I'm gonna commit this and we should find someone to raid. So does anyone have suggestions? Who's still online doing this? We're just gonna force release that one. And where are we? Okay. Twitch advent of code. We'll put in the advent of code tag. Now, Alka, is Alka still working on this? That might actually be the case. The Alka? Alka's still working on part 2. Okay, they might have they might be on the cusp. If you did part 1 that way, then you'd already have it. You're so lost? Well, feel free to ask questions anytime. I'm about to sign off, but you know, I like to explain and make sure people can keep up with what I'm saying here. We'll say hi to Alka.
Should I be subtracting from this side or something?
Raid.
Hey Stu, you already finished?
Yep. I'm all finished.
I'm just working out what the right math is here. No, that's no.
Great. Well, thanks everyone for stopping by. Have a good night. Good luck with the rest of your admin code. Say hi to Alka. Let's see how he does it.
I'm just slightly high over the examples.